the nature of fractals, part 1, and we intend to do part 2 next month at Vespers, and I think that's going to be May 13th, if I wrote it down right. So, but today it's the nature of fractals, part 1, and the board here. Oh, you know what the problem with that is? The way I have to show the board is kind of behind. Maybe Jim and I will just change seats. Hey, that's a great idea.
We'll do that.
Didn't think of that one before. Well, now what happened? Oh, okay, good.
Okay.
Yeah. So this is the nature of fractals, part 1. And the board work is what Elder Tess had on the board at the beginning of this presentation, mostly. And so what she started telling us at the beginning was that the previous presentation was called Q&A, the Change of Leadership, Part 2. And it was posted on September 3rd, 2020. And in that presentation, there was a question that came up that she didn't want to answer directly at that time. She wanted to do a review of fractals before she answered that question. And I want to remind you that this presentation was originally given in October of 2020, just a month before the US election of November 2020 between Biden and Trump. So no one knew at that time what the results of that election was. But when the question arose, as I said, she wanted to not answer it directly at the time, but the question was about a parable study that was done in the years 2018 and 2019, and it illustrated the reform lines depicting the external events and the internal events around the change of leadership in 2014. And this is not the original last president presentation. This is the one that came later, looking back at when we learned that the change of leadership actually began in 2014. So the question that was asked by many people was, if Trump is not elected this year, meaning 2020, what does that do to the parable study that we learned about in 2014? So, as I said, rather than answer that directly, she wanted to go into the some more information about the fractals, how our reform lines are structured and how they operate. So she began a discussion about fractals, which hopefully we all know is a portion of a longer line. So she reviewed the subject and continued to share information through the method of increase and enlarge. And she told us there are 3 types of fractals. The first 2 are exact self-similar and quasi-self-similar. Can you see those? Well, they're, yeah, so this, can you see my pointer?
Uh-huh.
Okay, good. This says exact self-similar, and unfortunately you can't see under there, it says quasi-self-similar. Oops. Oh, how do you do this? So
I was just gonna make it so you can see that other.
How can you
Oh,
see that? Oh,
okay.
I see. He knows how to do these things better than I do.
Okay.
You see, do you see quasi self-similar under there?
Yeah.
Okay, that's better. Is that better? To see everything? Okay,
Go down a little bit more, but yeah, we can see that self-similar.
okay. I'll just repeat that again. There are three types of fractals. The first two are exact self-similar and quasi self-similar fractals. The third type of fractal, which Elder Tess said that she did not really want to discuss, but she did mention that it is more about statistics and complicated numbers. So now Jim will give you some definitions.
Okay. Elder Tess found some definitions of the words similar, exact, and quasi in the dictionary. And similar means like. It also means resembling. And similar may signify exactly alike. If you had two things, you could say that they are exactly alike. They are similar, by which we mean exact. It can also signify a likeness in the principal points. So we generally use similar to denote a likeness that is not perfect. So similar can mean not a perfect comparison, but it can also mean exactly alike. So it can mean either one, you know. It's can mean quasi, it can stand for quasi, or it can stand for exact. Now, I'm gonna hold up these two pins.
I don't see.
Oh, I guess it
Yeah.
go over here.
Oh, that's better.
I'm trying to get my coordination here. So here are two pins that are essentially the same, but they're not perfect. They're not exact as far as color, but they are as far as shape, size, and function.
Principal points.
So they're like in principal points. Now, let's see. Now we have these two pins that are the same color, and all of their points they're exactly similar. They're similar in shape, size, function, and color. So similar means alike in principal points, or entirely alike when two things are compared. There must be two things or parts of things to compare. And when you compare things, you may say exactly similar in every point, or quasi-similar, which means partially similar or resembling. Only the same in some of the principal points. So they can be either exact or they can be quasi, but they're still similar.
Okay, so here we have, now we're going to talk about self-similar. So we have a tree here on the board, and it's a whole tree that we highlighted this part, and we highlighted a branch of the tree. So we can see that we're comparing a part of the tree to the whole tree, as it starts off like this before it branches off. So the one structure is called the self. And then you're going to compare a part of the self. Or you could compare this part of the self with that part of the self, as long as you have two things that compare. But in this case, we're talking about self-similar comparison. So the self is similar to its parts, and the parts are similar to each other. And they can be exactly self-similar or quasi-self-similar. In the study of fractals, it's part of the field of geometry mathematics. It's very complex. But these few terms and concepts, exact self-similar and quasi-self-similar, are the basics that we need to understand for the fractals in our lines. Although fractals have been seen in nature forever, it has only been since the 1970s that fractals have been studied in greater detail since computers and the improvement of technology. So Elder Tess tells us more about the mathematically generated fractal later in the presentation, but right now we will screen share. So I'm hoping that this is going to work.
Should I go ahead and start talking?
Well, let me try to screen share. Share content first. Oh, share content screen. Is it working? No, it's not working because,
Okay, so I need to switch over to yours.
yeah,
Okay, so I'm gonna switch over to you.
Then it's gonna probably get feedback.
no, it won't, no,
Yeah,
because
you
we
have
could
it-
still
you
use
have
the
that
same
on.
computer. I mean, the same,
Yeah, the speaker off.
you can still use this. We've done this before using the same microphone, but I always share screen on this other computer. The one that the microphone's off of. You can see that. Okay, I'm gonna push this and see what happens. Oh. Oh, no, back here. But I really need to be on the other one because that's where the document is. I could try emailing it. Would that be better? Can't access that.
Which computer is the pictures are on this one?
Mhm.
Didn't you just set that?
So are you changing it, Pam?
I did, I just have you up there now.
Me? Okay. Oh, start broadcast. Maybe I didn't even push the right button. How does that look? That look like-
Okay. I think it's working.
Oh, yeah, it says it's supposed to. So, oh. You are sharing the screen. Okay, thank you. I apologize to everyone for,
It's okay, we're all learning.
now let's see, you are sharing the screen. Okay, so I go like this and I go like this. Ah, there it is. But our picture's in it, but I guess that's okay. Okay. But can you see it from there, honey?
Mhm.
Okay, because I'm gonna go like this.
So we're gonna see fractals in nature, and these are self-similar fractals. We could not see the share screen on Elder Tessa's presentation, so we got ours from the internet. As we look, we can think about whether they are exact or quasi self-similar. So the first one we have here is the fern. And it's one self, one big leaf. But if we cut the leaf down here at the bottom, one of these branches off, it would be a smaller version of the whole.
Mm-hmm.
So
Go on.
we'll go on to the dandelion. And it's kind of similar. It's the whole dandelion looks like a stick with a fluffy top. But one spike from the top looks like a stick with a fluffy top. So each of these little, I don't know, I can't point to them
She
exactly.
called them spikes.
Yeah, yes, Tess called them spikes. And each one of them is similar to the whole. So you can see the little fluffy balls that are going around that big ball.
Mhm. And there's a single one left
Yeah, and there's a single one left
on the second page.
on the second picture, yeah. So then we can go over to the broccoli, and each floret looks like the whole broccoli, like a miniature broccoli. And they're in different sizes and scales. So let's go over to the mountaintop and look at that. The mountaintop, they become fractals because they follow patterns. And then we can go over to shells. And a slice of that nautilus shell there shows the same pattern. And then,
So you can compare the part to the whole.
yeah, you can compare the part to the whole. Same with the ice crystal. And in fact, I think the ice crystal really shows the fractal by, and that's more closer to an exact self-similar. But
Okay, go ahead. Go ahead.
all of these illustrations are all self-similar fractals.
Mm.
So because Elder Tess wanted us to see how complex fractal study is in mathematics, the final picture is not found in nature. It is constructed and computer generated. I will read the description. The boundary of the Mandelbrot set shows more intricate detail the closer one looks or magnifies the image. Usually called zooming in, the following example of an image sequence zooming to a selected C value gives an impression of the infinite richness of different geometrical structures present in the Mandelbrot set boundary and explains some of their typical rules. The magnification of the last image, the one to the far right, is about 10 to 10.
To the 10th power.
Yeah, 10 to the 10th power to 1. Relating to an ordinary computer monitor, it represents a section of a Mandelbrot set with a diameter of about 4 million kilometers. Its border shows an astronomical number of different fractal structures. So
the first picture was the one that she described to us
Yeah.
in the presentation.
yeah, and she was saying that everybody was saying that was not an exact,
It was quasi,
it was quasi.
because the first one looks like it has an indentation.
Yeah, the big one has like that heart shaped,
But ever after that,
they're all the same. But
so that is the example of the one that is generated by a computer. And it's very, as you can see through the magnifications, it's very detailed. And it goes on, practically, I guess it goes on to infinity according to mathematics anyway.
yeah, so the Mandelbrot set is a late study from the 1970s. The construction and study of fractals was made possible with the increased use of computers and advanced technology. Benoit B. Mandelbrot was a Polish-born French-American mathematician who is considered the father of fractals. He developed the mathematical study of fractals in the 1970s with his development of the Mandelbrot set. He referred to himself as a fractionalist or a fractalist and named the study of fractals. He also developed a theory of self-similarity in nature. The use of technology makes possible exact self-similar patterns, but most fractals in nature are more likely to be quasi-self-similar.
Paper number 3. Oh, there it is. So Elder Tess points out that it is interesting that the study of fractals came late in history. It was during the 1970s, and our use of fractals in this movement and our study of reform lines came not too long after that, from the beginning of our history in 1989. Okay, and at that time, as we learned about the reform lines and they were developing, we were given 4 reform lines back then, or as they developed in our movement. And that included the beginning of ancient Israel, the end of ancient Israel, the beginning of modern Israel, and the end of modern Israel. And then our understanding of those lines has increased over the last 30 years. More than 30 years now. We began to understand the line of 144,000, the Omega line. And we got most of that line from Ellen White. She gave us the Sunday law, the close of probation, and the second advent. Also, Tess wanted to show us that we used to, just to show how things have developed over the 30 years, we used to, and I know this was true when Jim and I first came in 2017, they used to have first angel, second angel, third angel, I'm sorry, I'm squiggling, but, and then over here, they had a fourth angel come in, and then they put 2 things beside here to kind of balance it out. And that's what we were studying, like I say, when Jim and I first came in. And we actually didn't understand it that well, which was just as well because it was found to not be fit for purpose, as Elder Tess said. And they found that it just didn't fit into place with the studies. And then as the study continued forward, it was in 2014 when things began to fit into place with the study of Ezra 7:9. And at that time, it started to show us that if you break this line, you could see 2 parts. If you break the line right here at the Sunday law, you can see the church and the world. And the church includes the priests and the Levites. And then after the Sunday law is when the Nethinims come into view. So that fell into place in 2014 after the study of Ezra 7:9. And then they noticed that each part of this line, when you broke them and compared them, showed you that each side was self-similar. So for most of the last 30 years, it's been one line of 144,000. But studying and working things out over the years showed us the fractals and the self-similar parts. And it continued after 2014 up to, we're still studying these things. And they found that there was the priest line, the Levite line, and the Nephilim line. But in 2018, the Midnight Cry message gave us the close of probation in 2019. And Elder Test tells us in this presentation that that was a problem for the FFA, and that's actually, was something that brought about or, made it more likely to split at that time because of their mindset. Their mindset was in terms of exact self-similar. So they couldn't understand that the end of this would be different than the end of this. And at that time, we weren't using the terms of exact and quasi. But our movement knew that the end of this could not be the same as the end of that. Because at the end of the 144,000, Christ comes and takes everyone to heaven, or all the righteous. So, and the 144,000. So they knew that this couldn't be the same because Christ would not be coming here. This was just in symbology. These things were symbolical. So meaning that they had some points in common, but they were not exact characteristics in every way. So, but we knew that there was a death decree here and a death decree here. We knew there was Jacob's time of trouble here and a Jacob's time of trouble here, but it wasn't the exact same event that would occur here and here. Does it? I hope this is making sense. If you have any questions, let us know. You can speak up. So our movement did try to teach the FFA about the quasi self-similar principle, but they would not listen. And even as late as July 2020, Tess said, they still were not listening and were sticking to that things had to be exactly similar and not quasi-similar. So we know that there was no direct death decree in our experience in 2019. But there were experiences such as the breaking up of unity and experiences that signified death during this dispensation, such as the death of George Floyd, the death of John Lewis, the death of Ruth Bader Ginsburg. So death was symbolized here, but it wasn't the actual death decree that is expected here. And that's because we're not dealing with exact fractals, but quasi self-similar fractals. So this is the end of part 1. And we're planning and we're intending and looking forward to continuing with part 2 next month. And I guess we have a little bit of time for questions or comments, if there are any. Okay, well, I'm sorry about some of our technical difficulties. And
Yes, no worries.
we found it very interesting. And I know in the second part, we've already, you know, looked into the second part and begun planning on that. And I think you'll find it very interesting because we're going to see some information that I didn't realize when Tess goes through the comparison of these lines.